Alright, so if you've ever done some front-end web development, I'm sure you must have come across this term called debouncing. It's when you skip multiple instances of an event when the duration between them is too small. So if there's minimal or no impact when performing an event 10 times versus just once, then skipping those events could save a lot of resources. A classic example would be a user typing in a search input field, and for every keystroke you would normally make an API call, maybe fetch some results for the generated search term. It's actually a wasteful way of handling that user interaction because 99% of the times a user knows what they want to search and they type the entire thing pretty quickly. So instead of making an API request for every keystroke, we skip all the initial events and we'll only run the last event. Again, if the time duration between, say, the third and the fourth character is significant, we will run the search for that event, but if the gap is small, skipping makes more sense. This way, we get the same search result that we normally get, but skip all the redundant initial requests. That's a classic debouncing example. It's a very important tactic when it comes to improving your application's performance and efficiency. Now, in your typical JavaScript interviews, a very common question would be to build a polyfill for an already existing native API or even third-party APIs. So array.map, array.reduce, array.filter, all these come under native JavaScript APIs, and debouncing or even throttling, which is again similar to debouncing, would come under third-party APIs as there's no native way to debounce an event, at least for now. When a new native API is rolled out, it's not implemented right away in the browser engines. So if you plan to use this new native API and you also cater to users who use like these dumb legacy browsers that do not support this new API, then you'll need to handle the scenario by creating a custom implementation of the API in a format that the legacy browser would understand. That's essentially a polyfill, a custom implementation of a new API providing the API's features to older browsers. So yeah, that's enough context for this video. We are here to look at the debounce polyfill and I'll take you through every step of how it works. So this should be the only video you should come back to if you ever want to know about this polyfill, period. So let's look at the very basics. The debounce function that we are building is supposed to run some other task or a function. So let's start with that. I'll directly start off with the debounce function invocation. And inside this, I'll pass in the function that we want to debounce. So let's call it click button. And we'll also need to provide a delay or the time gap between two events. Now, if the time gap between two events is more than what we have provided, the latest event goes through and gets executed. Else the previous event should be skipped or cancelled and the function should start counting down the second event's time gap. Let's also create this click button function. All this function does is console log a string. So this function is going to be mapped to a button that we'll have inside this index.html. So if we click the button several times with a time gap of less than a second between two consecutive clicks, only the last one should be executed. Rest all the click events will be skipped. So that is what we are trying to debounce. That is the gist of the example application that we are about to build. So speaking of the button, I'll also add it to the body here. I'll give it an ID. And over here, I'll just create a reference to the button. I'll also attach an event listener to this button. And the event that we'll be listening to is the click event. The listener that we'll be passing to this click event is going to be this debounce function. So essentially whatever we have here, I can just cut it and I'll paste it inside this event listener. Alright, so now let's create the actual debounce function. It's going to take in two arguments just like we have here, so the function and the time frame. Now while debouncing, ultimately we do run a single instance of the event. If I click the button 1000 times and the time interval between two clicks is less than 1 second, it will still run it once after the 1000th click. But even after the 1000th click, it's going to wait for a second to see if there's any new event. And if there's no new event after that 1000th click, only then will it run the function. So you can imagine this to be a delayed execution. And JavaScript has a native way or a native API to delay execution for a function. It's using the setTimeout API. So yeah, we'll also be using that. All I'm going to do is pass our click function and the delay inside the setTimeout. So setTimeout. So as of now, all we are doing here is delaying the execution of this click by 1 second. There's effectively no debouncing functionality as of now. To get that functionality, we need a way to cancel an event. So between two click events, we need a way to somehow cancel the first event when the second one runs before the first event's time gap expires. To cancel a set timeout, we first need a way to somehow access it. Luckily, set timeout returns a timeout ID, so we can store this in a variable. So all I need to do here is give it a variable name. Now set timeout will return a timeout ID, which will be saved inside this variable, and using this variable, we can essentially clear any set timeouts. Now let's save this once and run it in the browser. I'll open this file with the live server. You'll notice that even before I click the button, the console log message is already printed on the screen. That's because we call the debounce function directly on the add event listener line. You can see here that we are calling this directly. So I'll convert this into an arrow function. I'll save this. Now if I go back to the browser and click on the button multiple times, you'll see that the message for each click is printed after a 1 second delay. But there's a problem here with having a new instance of this debounce function attached to each click event. I'll actually switch back to the original implementation here and I'll explain you why having this debounce function for each click is a problem. So again, let's look at the flow. Now anytime there's a click event, a timeout instance will be created for that event. It will be stored inside this timeout ID. The second time when we click on the button though, we won't really have access to the first click event's timeout ID. It's going to be a new function altogether. So this timeout ID will also be recreated for that particular function. These are two different function invocations for two different clicks. A new variable will be created and there will be no memory of the old timeout ID. There's a way to solve this problem though, and it may not be as easy to understand, but I'll try my best to keep it simple. We'll be using this thing called a closure. So you see, a closure in JavaScript is like a special box that remembers things from the past so you can use them in the future. In this particular scenario, the thing in the past is the timeout ID from the previous execution. So what we want to do is create this timeout ID once and reset it anytime there's a new click event inside the time frame. So we'll first declare the timeout ID variable, then we'll move the rest of the execution inside an anonymous function. So this part is fine, this is not a problem. The rest of this section will actually move it inside an anonymous function. So it's going to be an inner function, a function inside this debounce function. This is what I'll be returning, and I'll move this over here. So now when we attach the listener to this click event here, the debounce function will be executed once and the timeout ID will be created. But this inner function's reference is actually what's attached to this click event. So the moment when I have this listener inside add event listener, the debounce function is going to be called, this timeout ID gets created, and whatever I'm returning from this debounce function is what's mapped to this click event. So this inner function right here. So this inner function is what's getting executed anytime we click on the button. So essentially the timeout ID is created even before anything happens, even before there's a click in the application, and it's set to undefined. When the first click happens, the inner function runs, so this function will run, and it will set the timeout ID to the ID that we get from this set timeout instance. Now this closure variable is changed from undefined to the ID that we get from the set timeout. Now when there's a second click immediately after that, this inner function will again run. It will create a new timeout instance and update this closure variable, this timeout ID again. So now this timeout ID will have the ID from the set timeout of the second click. But the problem here is that the older timeout instance, the previous click, that timeout still exists and it will run after the 1 second window expires. But now that we have the timeout ID of the previous event with us, we can use it to remove the timeout altogether using the clear timeout method. We'll do that at the beginning of every event. So the moment the second click happens, the inner function will run, and at the top here, we'll simply clear the timeout ID. So I'll use clear timeout and I'll pass in the timeout ID. So at the top, the timeout ID still has the older click event's value. We'll clear that timeout and only then we assign the timeout ID with a new set timeout, the one for the most recent click. The closure aspect here is that even after the debounce function has finished executing, the timeout ID is still stored somewhere. So when the debounce function executes here, it's immediately done with the execution. So ideally, any unused variables inside this debounce function should be cleared by the garbage collector. But since this timeout ID is used by this inner function, and this inner function is mapped to this click event, hence there's a closure that is being formed here, and hence we are still able to access this timeout ID. So one last time, let's look at the flow here. First things first, the click event listener is registered. So that is line number 10. This function execution is done right away and is removed from the call stack. But since timeout ID is being used by the inner function, it's part of a closure. So the initial value of the timeout ID is undefined. Now let's assume we click on the button 4 times. The first click runs this inner function, this function right here. When it runs this function, it first goes to this line, which is clear timeout. Since the timeout ID is currently undefined, this line won't really make a difference. So it's pretty much redundant when you have clicked the button for the first time. After that though, we create a set timeout instance, and the return value from the set timeout instance is passed to this timeout ID. The second click now has a timeout ID from the previous execution. The clear timeout is going to remove the timeout ID from the first click. It's going to clear that set timeout, so even after 1 second you won't see the execution for that first click. And we create a new set timeout instance for the second click. The timeout ID will now have the value from the second click. The same thing happens again for the third and the fourth click. After the fourth click, there are no new click events. So the set timeout callback will run after that 1 second is expired. And that's how this debounce polyfill effectively works. So I'll save everything here and I'll run this inside the live server. I'll open up the console. Now if I click this button 4 times, you'll see that we only get 1 execution. I'll also show you one more thing. So inside this function, let me attach a debugger. Now if I reload this, if I click on this button, the debugger view will open up. And you'll see that we have this closure section here. If I bring this up, you'll see that we have this timeout ID as well. This timeout ID is actually part of the closure for this debounce function. If I move to this line here, so I need to move 2 steps ahead, you'll see that we get this new ID. If I click on this button again, it's going to be replaced by the new ID that gets created from the set timeout for the most recent click. So yeah, that's how this debounce polyfill effectively works. Now, there are a few edge cases that we have missed, but this is mostly asked in interviews anyway. So normally the interviewer is okay if they think you know how things work internally. But I will cover the edge cases too in the follow-up video. This one's already too long, so it would be better if I break it up. Go watch the second one, and before doing that, do subscribe to the channel. You won't understand anything from this video if you don't subscribe. So yeah, it's up to you now.